Hey guys, so the hint I wanted to give you for number 1 is just to make sure that you notice the way the multiple choice is laid out. So the actual problem, I think, is fine. Okay, so we know that the domain is the x values, and this is just a set of ordered pairs that are graphed, right? So if I were going to graph all of these, it would look like just a bunch of ordered pairs. So I literally need to just write out each of the x values. So in order to do that for the domain, you just need to find the one that lists all those numbers. I just wanted to point out to you, and I'm putting in red because this is wrong, it does look like this one might be correct because it says x goes in between -2 and 6. But in order for that one to be correct, that means that the domain would have to be literally every single number between -2 and 6. And there's a lot of numbers in that domain that don't fall in between, right? So like 1, for example, is between -2 and 6, but it's not up there in the domain. So that is why we're not going to choose either one of those. And instead, you're going to choose this one, because this is the one that has each of those x coordinates explicitly spelled out. Same idea for the range. We know that the range is the y values. So what we're not going to select, so again, I'm going to put in red, we're not going to select this because this is saying it would have to be any number any number between -2 and 6, and that obviously isn't going to include every single number between 2 and 6. There's a lot that are left out, so it's not going to be either one of those either. So the range for this particular case would be this one right here, because that is the one that lists all of those individual x values. All right, so here's the hint for number 8. I'm using number 8, but it'll also help with number 7. This one's a little bit more, number 8's just a little tougher, so I figured I would use that one for the example. So it's asking which one is not a function, and it just gives you ordered pairs, not a graph. So what I did is I took option 1 and I graphed it. So all of the ordered pairs that go with option 1, you see them over here, right? And you'll notice when I graph them that none of them, you don't have any coordinates that are stacked on top of each other. So that if I were to put a vertical line anywhere here through the graph, it only hits one dot. Now notice the difference between this one and option number 3. So option number 3, I also graphed it over here, but then you can see right here, this one fails the vertical line test. Well, what's the difference between the two? In option 1, all of the x values are different. So what that means is that when you go to graph them, you know you're not going to have any coordinates that are stacked on top of each other, right? So if all your x's are different, it's going to be a function. But then for this one, see here how we have 2 of the same x's. They both have a -2, but they have different y values. So what that means is going to happen to the graph is that you're going to have 2 coordinates that are stacked on top of each other because they have the same x coordinate, but they have 2 different y coordinates, which means they're going to be stacked on top of each other, which means they'll fail the vertical line test. So how can you translate this idea into a shortcut that you can use on the homework? And here you go. I've kind of written this over here to the side. So if you have the same x values with different y values, so like an example here, we have 2 of the same x values. We have -2, -2, but they have different y values. So if that happens, you're going to get coordinates that are stacked on top of each other. So it's not a function. Okay, so I've also done the same thing here for number 9, just to show you it works the same way for a table as well. So in the first option, I graphed, well, it's option 2 here. So you see I graphed it over here. Since all your x values are different, when you graph them, you'll see that you don't have any any coordinates that are stacked on top of each other. So it passes the vertical line test because you only hit one at a time. But here in option 4, you have two of the same x values. In this case, it's a 3. They have different y values. So what happened here on the graph? You ended up having those two coordinates that are stacked on top of each other. So it fails the vertical line test because it's going to hit both of those coordinates. So whether it's on a table or whether it's on a whatever direction the table is in, again, the rule holds true. Same x with different y's. So this is not a function. Okay, the last 10 I want to give you is just to make sure you understand what these mean. These are called mappings, and it's really just another way of saying a table. It's just like a table where your x's are going to be on the left, your y's are going to be on the right, and you just follow the arrows to see what the ordered pairs mean. So, for example, since you have an arrow that goes from -1 to 6, that means it's the ordered pair, -1, 6. Because you have a 3 and the arrow is going over here to the 2, that is the ordered pair 3, 2. And because you have a 9 pointing over here to the 2, that's 9, 2. We've already established that if all of your x's are different, then this is going to be a function. Whereas, compare that to option 2. So here you've got an arrow going from -4 to 5. So you've got -4, 5. Here you've got an arrow that goes from 3 to 6. So you've got the ordered pair 3 to 6. But you also have an arrow going from 3 to 8. So you have two of the same x values that have different y values. So if you graphed them on a graph, they would be in two different places. They would both be over 3, but one would be at 3, 6, and one would be at 3, 8. So they would be right on top of each other. So that would be not a function.